How do we determine the nature of the roots of a quadratic equation without actually solving for the roots of such equation? We have this one, the value of b squared minus 4ac, which is called the discriminant of the quadratic equation. This b squared minus 4ac is actually found inside the square root sign of the quadratic formula. And this is what we are going to make use of in describing the roots of a quadratic equation. Use this idea. First, if b squared minus 4ac is equal to 0, then the roots must be real, rational, and equal. If b squared minus 4ac is greater than 0, meaning positive, and also a perfect square, then the roots are real, rational, and unequal. When b squared minus 4ac is greater than 0 but is not a perfect square, then the roots are real, irrational, and unequal. And finally, when b squared minus 4ac is less than 0, meaning negative, then the quadratic equation has no real root. Example, if we have x squared plus 3x plus 2 equals 0, before identifying the nature of the roots of a quadratic equation, we are going to solve for the discriminant of this quadratic equation, in which what we are going to make use of is the b squared minus 4ac formula. Now, before we can make use of b squared minus 4ac, of course we need to find out the values of a, b, and c in the given equation. Now, our quadratic equation is already in its standard form, therefore the next thing to do is to identify values of a, b, and c. Now, given this one, we have 1 for a, b is 3, and c is 2. Now, using these values, we are now going to substitute these values to the formula. So we will have, instead of b, we're going to write 3. And then following the formula, we have minus 4. And then times a, which is 1. And times c, which is 2. Now, 3 squared is 9. Negative 4 times 1 times 2 is negative 8. And 9 minus 8 is 1. Now, going back to our this discriminant formula falls under b squared minus 4ac, which is greater than 0, and also a perfect square. 1 is greater than 0, and 1 is a perfect square. Therefore, the roots are real, rational, and unequal. So we are now going to write real, rational, because it's a perfect square, and unequal. Now let's have this one. X squared minus 4x plus 4 equals 0. Similarly, we are going to solve for the discriminant value of this quadratic equation. Now again, see to it that the quadratic equation is in its standard form. Now since this one is in standard form, identify the values of a, b, and c. Now, in this quadratic equation, we have a equals 1, b is negative 4, while c is 4. Substituting these values to the formula, we have negative 4 squared minus 4. Instead of a, let's write 1. And instead of c, we are going to write 4. Now, negative 4 squared is negative 4 times negative 4. That is positive 16. Now, we have negative 4 times 1 is negative 4 times 4. That is negative 16. 16 minus 16 is 0. Now, this discriminant value falls under number 1, in which b squared minus 4ac is equal to 0, and the roots must be real and equal. So we are going to write now real, rational, and equal. Next example. If we have x squared plus 2x plus 5, we are going to solve for the discriminant value using the formula, the same formula. So this is in its standard form. Let's identify values of a, b, and c. A here is 1, b is 2, c is 5. Substituting these values to this formula, we have b is 2, so you have 2 squared minus 4 times a, which is 1, and times c, which is 5. Now 2 squared is 4. Negative 4 times 1 is negative 4 times 5, that's negative 20. 4 minus 20 is negative 16. Now this quadratic discriminant value falls under this one. So b squared minus 4ac is less than 0, meaning negative. So the quadratic equation must have no real. Next example, 5x squared minus x minus 2 equals 0. When the discriminant formula is b squared minus 4ac, identify values of a, b, and c. Now with this, we have a is 5, b is negative 1, c is negative 2. Substituting these values to the formula, we have negative 1 squared minus 4 times 5 for a, and then times negative 2 for c. Negative 1 squared is 1. Negative 4 times 5 is negative 20 times negative 2, that's positive 40. 1 plus 40 is 41. This discriminant value falls under number 3. b squared minus 4ac is greater than 0 because that is positive, but it's not a perfect square. So 41 is not a perfect square. Therefore, the roots are real, irrational, and unequal. So we're going to write here real, irrational, and unequal. This is an application of the discriminant formula. Now determine the value of k so that each equation has real and equal roots. Now we have here the given is 3x squared plus 4x plus k equals 0. How do we solve for k? Remember that when b squared minus 4ac equals 0, the roots are real and equal, which falls to the condition that is given. So to do that, we need to use the discriminant formula. But of course, first, we have to identify values of a, b, and c according to the given. Now here we have a is 3, b is 4, while c is k. How do we solve for k? Now for this to have a real and equal roots, this b squared minus 4ac value must be equal to 0 because that is the condition given. Alright, so substituting these values to this formula, we have 4 squared minus 4 times 3 and times k, and that must be equal to 0. 4 squared is 16. Negative 4 times 3 is negative 12, and then we have k. So that's equal to 0. To solve for k, of course, we need to transpose 16 to the other side. So this will be 12k is equal to negative 16. Then finally, divide both by negative 12. K is equal to, let's cancel out the two negatives, or negative divided by negative is positive. Now, 16 over 12 cannot be, 16 cannot divide 12, but we can reduce this instead to lowest term. And the lowest term for this is, of course, 4 thirds. So k is equal to 4 thirds, so that this quadratic equation will have a real and equal roots.